We have here another wonderful exam question for series. This is in an integral calculus course. This is from an exam. So both parts of this question concern this series right here. And it looks like a bunch of mumbo jumbo, but let's think about it for 1 second. Now, before we get into that, we're going to do question A here, and I'm going to say 5 minutes is the timer. So if you think you're ready for your Calculus 2 exam, then what I would say is this: test yourself. Give yourself 5 minutes tops for this question. You have to get the perfect answer, and you can't use any outside help, no AI, nothing. Just a pen and paper from the question, get to the right answer. If you can do that in less than 5 minutes, then I'd say yes, for this type of question, you are exam ready. If not, if anything else, you are not exam ready. You need to practice more. That's a big mistake students make. All right, so we have this series here. Now, here's the question we're going to do together. Show that the series S converges absolutely. So remember this sentence: show the series S converges absolutely. And on the next screen, show the series S converges absolutely. I have that here just because the walkthrough is a little more clear here. We have more room. To show absolute convergence, we need to take the absolute value on this series and show that that converges. Before we do that, I just want to get an intuitive feel on this. So on the numerator, we have 24n squared. That's a polynomial. And then we have e to the negative n cubed. This is going to go in the denominator because of this negative in front of the n cubed. That is an exponential. So we have polynomial growth from the numerator competing against exponential growth from the denominator. So which one of these is going to win? The exponential growth, right? Big time. It gets big way faster than the polynomial growth. So this fraction as a whole, right? It's something small over something huge, goes to zero, and it goes to zero fast, super fast. So that just means that here, when we're computing this, when this is going off to infinity, it's going to zero super fast. So the way we formalize that is with the ratio test. So we apply the ratio test here. So we take we want to look at the fraction of these terms as n goes off to infinity to see what do those fractions of those terms look like for really big values of n. And yeah, we throw that in here. This is the formal way to do it, as I said. There's one little trick here, which is to know how to expand with the difference of cubes. Otherwise, it's going to take you beyond the 5-minute limit, probably, unless you're super fast and tight with your computations. But if you know the difference of cubes expansions, then this is no problem at all. And then there's nothing really here, no tricks here. You just compute the limit, it's zero, and therefore it's absolutely convergent, which they tell you you're supposed to prove, so that makes sense. If you want questions like this, go to prettygoodprep.com.